Not record yet. All right. Does anybody want to try this quickly? Because of our time, we'll have a lot to do. So we have another question.
Yeah. Can you just zoom? Can you just zoom back? Let me emphasize something. Can you just zoom back to the question? No, zoom out.
Initial question.
No, this one. Just zoom out a little bit. Let them see. Now, gentlemen, what is this telling us? What it's telling us is that you are come up. No. Just zoom out for them to see the question. The whole question. No. Zoom in. Like the whole thing. Let them see the question. I want to see the question. Good. Okay. Now, what the question? Yeah, good. Thank you. Now, what this is telling you is this. We are investing 200,000 on PV design or batteries and inverters and what have you. And when we check our energy bill, there's a reduction by 40,000. So the question now, is it a worthwhile investment? And that investment will last for 10 years, right? But you also have to borrow money at 10% to do that investment. Now the question is it a worthwhile investment? And that's why I told us before you came, I said, MPV is a very standard in terms that they use to quickly evaluate your proposal. Now, if I had asked a layman would say 40,000 every year for 10 years will be 400,000. But now you can see that when a engineer, she discounted it, the real value is 245 and not 400,000 that a layman will assume. Oh, in 10 years, I'm going to make 400,000. I'm going to save 400,000. No, what you are technically saving as of today worth of money is 245. But then it's still a good investment. Why? Because the NPV is positive. And that value is 45,000. It means your net gain, if you go into this project, you are just being richer by 45,000. That's the meaning. So it's a good investment, it's worth doing. But if there are other investments, you should also evaluate them and then make a choice and know if the second one is giving you a higher money, right? So this is the idea of discounted. You can see it in plain view that a layman will assume because I'm making 40,000 naira every day, every year, I'm automatically going to make 400,000. No, it's not possible because the money is losing value at the rate of 10%, or you borrowed money at 10%, right? So it is being discounted. Thank you very much.
Thank you, sir. So that's a very good explanation there. So this is very, very important. So the next question is also similar. It's just a normal, typical example of a truck. Just to emphasize, let me just help you to quickly calculate it. So you buy a truck at $9,000. You want to increase your sales with the truck of 2,000 over the next 5 years at the cost of capital. So the same process, you have an initial investment, 9,000. So you calculate the present value. So Excel makes it very, very easy to calculate this. Like he said, we'll do an example of where we basically compare two projects, so we can basically understand it vividly. So here you have a rate of 10% as well. The number of years is 5, and then $2,000, for per sales per year. So we can basically calculate. So we can see that this is 7,000 as the total is getting. And then if you subtract this minus the initial, you see it's negative. And just like Engineer Uche said, if you had calculated 2,000 for 5 years, it gives you 100,000 using normal simple process. And that's mixed as if you move 10,000 from 9,000, you have to make it a profit. But in actuality, because of the cost of capital, the interest rate, you lose the money. And so this is the actual loss. So understanding this is very, very critical, very, very critical when we are explaining projects and net present value. Because of our time, let me quickly jump. Another important variable we should always discuss is IRR. IRR of a project is basically where the net present value is equal to 0. So it's basically the interest, the rate at which the net present value is equal to 0. And of course, it must be higher than the cost of borrowing, just like I was explained. For example, you go and take a loan from a bank or from an investment company, and you want to calculate if a project is feasible, why should you invest on that project? But you must calculate the IRR, internal rate of return, to know if it's a feasible project. And if the IRR is greater than the discount rate or the interest rate, of course, it's feasible. If it's not, then you know that, yes, it's not a very feasible project. So the formula for calculation of IRR, of course, there's a lengthy calculation too. Usually you want to use calculation methods. We engineers, we like this. It's a typical example of a project. So a proposed project requires an initial capital investment of this, 20,000. The cash flow generated by the project is shown below. So these are the various cash flows. So what you do is that you keep guessing the interest and discount rates. But what the target is to get an NPV of 0. So you keep guessing. So with a discount rate of 8%, the NPV is this value. With a discount rate of 13%, is 65, it's negative. For this one, it's 495. So you can see that it's either between 12 and 13, and there's another method they use to calculate the exact value of the IRR. But like I said, Excel makes these things easier. So I'll give a typical example of using Excel to also calculate IRR. So very, very easy. So this is basically the cash flows for that same new truck. I think the new truck, let me see the initial 20,000. Okay. So basically you go to financial, go to IRR. There's it. And basically you just capture all the values, including the initial investment. And there you go. It shows you the percentage. So this is the percentage where NPV is 0. To confirm that this is the percentage, if we, for example, want to calculate the NPV, we can come here and also use the interest rate. Let me do this so that you could, just to verify that the interest rate is, the NPV is actually 0. So the rate is this rate. The number of years is 6 years. And then the values. 20,000. The rate is 85. Number of years is 6. And if you calculate this,
the payment is not 20.
Okay, what's the payment?
Go up. I don't know, because this is the annuity. The PMT is the annuity.
Okay.
So I don't know
what we should do. Let me use PV. The easier way to use PV first. I like using that.
Yeah, PV of cost, PV of savings, yeah, and then subtract the 2.
So yes, so PV. So like I said, the rate is this value. The number of years is 6, and then the PMT. Let's use the savings. So you get this. So this is that value, and then you just subtract it. If you subtract it, it's going to give you about this.
0,
so basically, most times you.
Hello, Ishi. I think why you got it right. The difference is that the payment is supposed to be uniform.
Yes,
so if the payment is uniform, this 59 naira, it will 0 out. So, but it's correct.
Yes. It is 0 out. Yes. So most times companies use this to basically compare what's the benefit of investing in a project instead of leaving it in a bank. For example, if I can put my money in a bank and I earn a certain amount of interest instead of doing a particular project. So most times you use IRR to basically understand those kind of concepts. Okay, another concept is life cycle analysis. life cycle costs. I think you also mentioned this. So it's the overall value of cost of the system over its lifetime. So
change your screen.
life cycle.
Change your screen, sir.
Okay, no problem.
Excel, yeah, to the PowerPoint. The Excel is still showing.
It's still showing. Okay, okay. Can you see the screen now?
Yep.
Okay. All right. So another concept that is very, very important is life cycle cost of a project. So the life cycle cost is looks at the overall costs that you spend throughout the lifetime of a project. Like, a project has a span, a period of time, and during that period of time, it has income and expenditure. So the life cycle cost basically looks at the overall costs you spend over the time. The cost includes the capex and the opex. So, for example, you're deploying a solar panel project somewhere. It looks at both the capital cost for all the procurement and also the operating costs and gives you the overall costs. And the major concept people that we very use, especially to compare between two energy generating systems, is levelized cost of energy. So it basically measures the lifetime of costs over the energy produced over the lifetime. So the lifetime of costs divided by the energy produced over the lifetime. So it's how much each kilowatt of energy will cost. So if, for example, you are using a diesel plant, what was over the lifetime, what was the cost of energy per kilowatt hour? And also, what if you're using a solar panel producing, what is the cost? So basically, with this simple LCOE, you can basically calculate the overall cost of one system over another throughout the lifetime. It gives you the equivalent in the monetary equivalent per kilowatt hour. So maybe, for example, solar is $0.05 per kilowatt hour for a project you have deployed. And now say, okay, if I use a diesel generator, by the time I consider the price of diesel and everything, the price of that is maybe $0.90 per kilowatt hour. So I would definitely want to deploy the one that is lower and can give me over the lifetime of the projects. So this is one of the major also concepts engineers use to calculate the cost of energy. And Engineer Uche, any concept before I go to the interest table?
It's just to explain to them go back. I need to explain to them how, before you go to interest table, how to quickly use the interest table. But it's good that you explain something about this, so that when they meet them at the interest table, they'll know how to make use of it, especially here, right?
Yes.
I saw it in your slide also.
Yes. That's
so I don't know how to read off the interest table. Now, gentlemen and ladies, the interest table is for manual calculation if you are not too conversant with Excel. But I know that as we are engineers, it's good for you to know the first principle of everything. Then after the first principle, you now know the computer application. So in the next 30 minutes, he's going to take us through the use of the interest table, such that if, for adventure, you're not too proficient in Excel, you can fall back on the table. And the good news is that in the professional exams on this course, whether the CEA or CEM, it's an open book, right? And they will allow you to use interest table. Interest table is just like those 4-figure tables that we use in school. And for those of us that are engineers, civil engineers, we know that we always have these charts and tables that we use to do our design. So it's a common place. And interest table is also a common thing. If you go to Google, you'll see more than 1 million interest table. They are just the same thing, because interest is just constant. So engineer, you go on and make that emphasis.
So, all right. So I put the interest table on the chat box. So for those who can download it quickly, but I will share my screen as well as I explain. So the concept from it is, of course, is the time value of money. P, most of the time, is the present watts. That's the amount of money at the present time as stands today. F is the future watts over the lifetime or over a period of time. N is the number of interest periods. A is the annuity. So the annual consecutive end of period amount. So this can be end of year or end of a month. And I is the interest rates. More importantly, on the interest table is what I want to know and what given what I know already. So most of the time they give you the interest rates, they give you the number of years. And the one by your left, like this P, is what you're going to find. And they give you the other one. So for example, in this particular question, find find P, sorry, given A and I and N. So I will explain it further on this chart. So basically, these are the various factors that are in the interest table. So the first one, in simple terms, is single payment compound factor. You are going to be given, you're going to find F, which is the future what, and you're given the present what, the interest rate and the number of years. So you're going to find F given P. Like I said, there's a formula which you can easily find the future value, right? The second is the single payment present what. You are given the present what. You are to find the present what. You are given the future what of a project. So that way, from here, you can see that you are going to find P given F, the interest rate, everything that is under this place is what is going to be given. And this is the formula. Then the same thing applies here. You are given you have to find the present what when you are given the annuity. And also capital recovery factor, you are given you have to find the annual payments or the monthly payments given a present what. Every other thing is given, the interest rate and the number of years. So most of the time, capital recovery factor, it helps us to determine the present value of a series of equal annual cash flows. So we want to know the present value of annual cash flows. So for example, now you want to take a loan. You take a loan of $1,000, which you will pay over at 7% over a period of maybe 5 years. And you want to know how the present worth you want to know the annual, how much you'll be paying, annually for the 5 years. You can use this to calculate it. The opposite is the sinking fund factor. Sinking fund factor, you also want to know the annuity payments monthly or yearly, but you are giving the future amount. So some banks use that. So for example, there's equipment we want to buy in 5 years' time that costs $10,000 to buy new listing. So we want to know how much money do we need to be saving or do we need to keep in one place that we, considering the interest rates and the number of years, that will result to $10,000. So you have to determine the annuity, the annual amount, given the future odds and every other factor. And the last one, the same thing, you have to find you are given the annuity and to determine the future factor. So I'll show you a typical example of, let me share my screen to show you the interest table before we do examples. So this is how it looks. Can you see my screen?
Can you just go back to the last script? Let me just say something.
Okay.
PowerPoint.
Yeah, can you see it? It is there.
Yeah, I can see it here, but not full. Right, now, if some of us recall, during our school days, the mathematical expression was what we were taught. But as you know, the world has gone beyond that. So this formula that he has just shown now is what you'll be encountering with interest table. So let me come with the first one, which is the first two are single payment compound amount. Single payment means I borrowed money in year 1 and I'll pay back in year 3, right? So I will just simply, if I'm looking for the future amount, I'll simply multiply the present amount by the table factor. So whatever you see in parentheses is just one number you pick up from the table. But at what point you pick it up from the table is at the particular interest and at a particular number of years or number of payment period. For the second one, I'm looking for the P, but I have the F. So what I'll do, I'll multiply what I have, which is the F, by the table factor to get my P. For the third one, which in other words called uniform series present worth. I'm looking for the present value, but they have given me the savings, the annuity, the annual worth, right? So what I want to do now is simply multiply what I was given with a table factor. So I don't need to go into all these mathematical expressions to cram them or to know them. It's outdated. So it's either use interest table or use Excel. In the exam, you will not be allowed to use Excel. So it is good that you learn interest table. But in your day-to-day work as a design engineer, of course, you sit down, you use your interest table, you use your reference materials, and you come up with your design. So it's important that you have a mindset of how this thing works. Simply what I'm given, multiply by a factor from the table. So it is not how you go to the appropriate table. That is what she's going to show us now. Thank you. Please, back to you, sir.
All right, sir. So the interest table, like he has explained, for us that have downloaded it, it shows basically you can see the percentage. You know, it has different interest rates for every table, for every page. Sorry. So here is 0.25. Here is 0.5. Goes down to go to maybe 1%. So these are the single payments that he explained. So you're going to find, if you are going to look for example, the future value given the present value, you just get this value and multiply. The same thing with the present. If I want to find the present value and you're giving the future value, you just find the exact value based on the number of years and the interest rates, and you just multiply it. For uniform payment series, exactly the same thing. So we're going to solve 1 or 2 questions with this so that it will make a lot of sense. Let me share the Excel back. Okay, can you see my screen? Can you see my screen?
Yes, you can see. Yes.
Okay, so
Yes.
I will use good methods in this particular case to explain, to explain this. So a new lighting system will last 6 years and save 5,000 per year. The company purchasing it requires hurdle rates of 15%. In order to meet the commitment, how much can they pay for the lighting? So from here, we know that the rate here is the hurdle rate, which is 15%. So the number of years is 6. The annuity, because they say 5,000 per year, right? So they're asking you to find the future value. So let me first use, so it means that we're looking for P. So you have, they're looking for F and you have A, and also the interest rate and N. So if we go to the interest table, we are going to look for 15%, and we're going to look for 6 years. And we are looking for the future value at an annual. So let me share the interest table. So we'll go to the 15% now. So this 15%, we're looking for the future value and A. So the future value, you can see that this is F here, and we have the annual. So this is what we use. So all we just need to do now is to trace where we have 6 years. This is N is the number of years. So N6, you trace it down to this value. And that value is 8.754. 8.754, because basically we are giving the annuity, but to find the future value. So we just must take this value, 8.754, and so the answer will just be 8.754 multiplied by the annuity, 5,000. So the future value will be this times this. This times this. So this is the future value of this. Like I said, we can also use the Excel to calculate this. So we also go to future value, FV. So you get the rates, which is 15. Total number of period, you just range is 6, and then 5,000. And put a minus there. 0.15.
Ishi, can you be using the cell operation so that if they want to change the interest rate, I don't know, can be just be clicking the cells. I always advocate for that. Yeah. So go back. So I want to change. Yeah. So that they can change the interest rate at any time. Yeah.
Okay. I'll be using the cell value of putting it.
Yeah.
So you can see that you can see both this and this are the same. So it just shows you that both you can use Excel and also you can use the interest table. Let me do another question that compares two projects. So it will make a lot of sense for us. So this is a typical example of a question that is comparing. So a company considers two power projects. The first project costs $85,000. So that is the initial investment, and we save $23,000 each year. So the second will cost $75,000, and we save $18,000 each year. Project 1 will last 12 years, and project 2 will last 8 years. The company has a discount rate of 10%. So from here, based on the question, as engineers, there are different methods you can apply based on what is given to you. So first, we can basically narrow down what is given to us. So for project 1, we have the interest rate at 10% for both of them. The number of years for the first project is 12. Number of years for the second is 9. The present value, which is initial investment, is 85,000. The present value for this is this. And then the annual payments and what you savings is 23 for this and 18 for this. So the question is now, which of these should the company go for? So there are different methods. You can use the net present value method, or you can also use the annuity method to calculate this. So let us see, using the annuity method first to calculate this. I will use Excel to calculate it, and maybe we can also use the interest table method. So to calculate the annuity, basically, annuity, you go to financial. So you have the rate, right? What is the rate? The rate is 10%. The number of years for the first project is this. And then the present value, okay, so I should be using the cell. Yes, let me use the cell. So the rate is this. Number of years is this. And then the present value is this. And press OK. So this gives you using annuity method, the annual savings, actual savings. So to get the net, what you do is to subtract what it is given that if you save minus this value. This gives us the net savings. So for project 2, we'll compare that to do the same thing. PMT. The rates, number of years 9, present value 75. Okay. And the nets is equal to this minus this. So we can see, obviously, that the net for project 1 is definitely better than project 2. So this is a typical example of how you can compare, but this is just one method using an annuity method. Let us use the present one. Let us use NPV. Let us know what is using NPV to calculate this value, to know which of them gives us a better one. So I'll calculate the present value. Same thing, financial, present value. So put a rate, put the number of years. The same thing, but do the same thing for this. Present value. Rates. So basically, with the present value method we are using, we are basically going to compare the present value of this with the actual. So to be able to see the difference. So knowing fully well that this is supposed to be, so this is equal to, just ignore the signs. This, let me just use plus. No. And for this, we do the same thing. So obviously, this, let's ignore the signs, but I can put a minus to make sure that it's this thing. You see, this one has a higher net present value than this. So this definitely shows that project 1, either using the NPV method or the annuity method, it's a better project. So these are basically ways that you can easily calculate which project is viable, more viable, based on the estimates that are given to you. So let me also use the what they call it, the interest table, to also do this question. So this question, we're looking for the annuity. We're given the present value, the interest, and the number of years, right? So all we have to do is to go to, for the first one, 10%, 12 years, right?
Your screen.
Yes, I will change it to down. So we'll go to 10%. I will see 10% here. So at 10%, we're looking for A, and we have been given the present value. So looking for A, right? This is A, the annuity, where you are giving the present value. So you now go to the number of years. The number of years in this case is 12 years. So you are 10%, 12 years, looking for the annuity, you just trace it. So you have 0.1468. 0.1468. So all you do is just to multiply, let's put it here, 0.1468. So to get the annuity, all you do is to just multiply the present value. This multiplied by this. So ignore the sign too, because of this sign here. So you can see that this almost gives us the same values with this. You can do the same thing for this. Go to the interest table for 10% at 9. So 10%, number of years is 9 for the same for the same annuity present value, 0.1736. So add that 0.1736. So if you calculate it, all you do is to multiply this times this value. So you can see it gives us exactly the same. So if we do this for 9% value, it's going to give us the same. So because of our time, let me not do one question. I don't know if we have time for a participant to do one question. Engineer Oche, can we do one more question?
Please go ahead. Go ahead, please. While I was speaking on the back, when they start, I'll be talking.
Okay. All right.
Already, I've uploaded other version of interest table on the platform. And before I forget, we'll introduce the question while they're solving it, then I can go ahead with what I want to say. Introduce the question, please. Yes.
All right. So this is another question. The company has asked you to look at 2 power projects. Each project will last 8 years. The first project costs this, and we save this each year. Second project costs this, and we save this each year. The company has a discount rate of 12%. Which project will you recommend? So I don't know if any of us can give it a shot using either the Excel and interest table and put your answer on the chat box.
For the Excel, they don't have it. But let me share it with them now, right? Then for the, let them start with interest table. First principle first. So let them start with interest table. Then they will now use Excel to control, as control.
Okay.
Yeah.
Okay.
If can you share this interest table? We have to close this. Can you share this Excel with them?
Okay, I should. Okay, let me share it.
Yeah, but you have to close it. If you didn't close it, it won't share.
Okay, I just send it to the chat box. You mean?
Chat box, yes, yeah.
Okay.
I can't remember where mine is when I send it to you. You know, I sent you the latest version, edited LCC and cost estimation. Yeah, so share that one. While we are sharing it to solve this question, a couple of us are in this platform. We have not made payments. I'm aware of that, so I'm not ignorant of that. Please, I want to encourage you. This payment is not free, right? This training is not free, and it cannot be free. In fact, to write the certification for this exam, it costs $1,500. So you know what that means. But we are offering this training for 50,000 Naira for 5 weekends. Already, I'm thinking of coming up with a makeup class where we'll discuss this Excel thing, because I know that is a new area for some of us. Some of us are just lost. Don't worry, I know how it feels like. But I'm going to help you with all these things. At the end of the day, I'm going to send you the video, a previous online video of this training for 3 hours. So for today's video, I will convert it to day 2 video, because that one is more comprehensive. What I mean more comprehensive, we started recording late. I just keep my mind, right? I started recording